So number one, when it says a straight angle has a measure of, we're just writing down the degree measure in a straight angle. All right, and Mo, that's how many degrees for number one?
I guess 102. Is it 104?
What did I give you? Oh yeah, don't do that. Don't look at that. Yeah, yeah, don't look at that. I guess you know the first question on test tomorrow. Sorry, I just made that this morning, so there you go. Okay, now Mo, number one. What'd you get?
72.
Good. So this is a straight line. It's a linear pair, supplementary. A lot of different ways we've referenced this, but a straight line is always 180 degrees. So if I have 104, we do 180 minus that 104. One of the first theorems that we did right after winter break, that's our 76 degrees. So that's a linear pair, we call that. Julia, what do you think for number two, Julia? Ooh, not quite. And this is why I put these back to back. All right, just to make sure we understand. So this is what is it? Good. Do you remember why? What these angles are called? Good. So these are vertical angles. They're opposite of each other, created by these two lines. So when they're across from each other and they're created by the same two lines, those are what we call vertical angles. Those are congruent. So just keep those straight. This is a linear pair. They add up to be 180. Here you're going to set them equal to each other, which in this case is just 124. All right. So same idea with 3 and 4. Like numbers 1 and 2, linear pair, vertical, but you can just figure out what they are numerically. 3 and 4 are the same exact ideas, but now you're going to have to do some algebra to find these out. So when we look at these, I'm going to go back to you now, Julia, just make sure we're squared away. These are which ones? The linear pair or are these vertical? Vertical. So these two angles, just like number 2, have to be equal to each other. So just like Julia knew this is 124, so this had to also equal 124. They're equal. We just got to do a little work for this. We got to do some algebra. So that 2x plus 21 angle better be equal to the 5x minus 36 angle. And then now this just leaves us with some work as we go through solve these equations, all right, which at this point we should be pretty good with. All right, so we go through those steps, subtract our 2x. Add that 36 over. Let me create a little space here. What do we get there? 57 equals 3x. Yeah, that goes in nicely. I think all I wanted was x, correct? Yeah, for all of these. All right, divide by 3, and then that should equal 19. Okay. Again, these are vertical. These are angles that are across from each other. When we now go to number 4, these are angles, when they're not across from each other, if we use our proper words, we would say these are adjacent to each other. They're next to each other. And these adjacent angles create a straight line. So just like up here, Mo talked about how these had to add up to be a 180 because they're that linear pair. These must also add up to give us this full 180 degree angle. So now you're adding those together and setting them equal to 180. That's a big part of a lot of these. Are we setting things equal to each other, or are we adding them up and setting them equal to something else? Okay, 90 degrees and 180 typically. All right, and then solve this. So you're going to combine your like terms. We have 9x's over here. If we take our constants and add those together, that is what, 81? All right, let's hope this works good. So subtract our 81 over. Oh yeah. All right, we get 11, hopefully. Yeah, so x should equal 11. Okay. So linear pair versus vertical angles. Know the difference. In that one instance, you're setting them equal. The other instance, we're adding them up, setting them equal to 180. Okay. So that's those first 4. All right, the next 2 gets in the idea of bisecting things. And in this case, we understand how we read this. This is a ray. So the ray drawn from B to E, so this right here is the ray that gets drawn from B to E, is going to bisect. Bisect just means cut in half this big angle from A to B to C. So if that got cut right in half, what that tells us is these two smaller angles have to be equivalent to each other. All right. And then I give you those two smaller angles, ABE. So ABE, this has to be 2x plus 6. And then ABC equals 3x plus 40. Oh, hold on. So ABC is the big angle, 3x plus 40. Actually, I want you to try this one. See what you think here. And then I ultimately want you to find the measure of that big angle ABC. Okay, doing it in my head, I think we get 124 if you get through this correctly. We'll see though. Anybody? Okay, here's why this one's a little trickier. Just because the first thing I gave you, this ABE, is this angle right here. And then the next one that I gave you, this ABC, is the full angle. So it's not just this little small one right here. All right. Now we've done some of these where maybe I give you this full angle as a degree measure. But in this case, we're given this one. We want this full one. So Ella, how'd you set this up, Ella?
So I started by taking 2x plus 6, and then I put it twice, and then I set it equal to 3x plus 1.
Good. So if this guy is an angle bisector, doesn't this angle here and this angle here have to be the same exact degree measure? If it was degrees, it'd be like 40, 40, 30, 30. So when I tell you that this is a 2x plus 6, then this smaller angle here must also be 2x plus 6. Then she said those two together. So then she just added those, the 4x plus a 12 added together, those two angles, those have to equal the big angle of 3x plus 40. All right. So again, when we bisect something, we create two equal, in this case, angles. We've also done it with segments where the segments are equal. So in this case, those angles have to be the same. They're both 2x plus 6. So that creates this 4x plus 12, and then that's your equation. And again, at this point, we got to be able to get through these, and I think most of us can. So I subtract that 3x over, subtract your 12 over, and then x equals 28. Again, test 50% of your grade tomorrow. Make sure you're answering the question. This is good to know, and it could very well be what I ask you tomorrow. It's what I asked you in the first 4 questions. In this question, however, I am asking you to find the measure of angle ABC. So we now need to take this. Here is ABC. So I'm going to take that 28. This is smaller here. And I need to plug 28 into this expression that we had for ABC. All right. So the measure of angle ABC was 3x plus 40. We now know the x value is a 28. So after all that, Ella, what'd you get? 124 degrees. Okay. Tricky one, I think. Makes you think a little bit. All right, read number 5. Should be a little nicer one. So now set that one up. See if you understand how it's very similar didn't label this good. This should be number 6 here. So that do the next one. This guy, how it's very similar to number 5, yet at the same time it's a little bit different because it starts out. Well, you just read it and see if we can process all that. All right. So now this one, it starts out the same. I tell you that BE, that ray, bisects the big angle, ABC. So that blue in mine is cutting the big angle directly in half. And then I tell you that ABE is this 19x minus a 6. And then this angle now I give you is EBC. So from here to here to here, the other small angle now I give you 17x plus 2. So this is really actually similar to these first 4, where we want to know, do we want to set them equal to each other, or do we need to be adding them together and setting them equal to something else? In number 5, I needed to add them together and set them equal to the big value. But now that we are given each of these, don't these two angles have to be congruent to each other? All right, so Saad, what'd you do?
What's it called? I put 19x minus 6 equals 17x equals 2.
Good. Now we want to set them equal to each other. All right. And then from there, although it doesn't look like you're going to get a great numerical value, so sorry, it looks like we get a decimal correct. No, that's a 2. Sorry. That's my bad. There we go. That'll be better. So subtract your 17x over. All right, what do you end up getting then, Asad?
You end up getting x equals 4.
Good. So x equals to 4, but then just make sure that's what we're looking for. What this says you're looking for is ABC. So what did you do to get ABC, Asad?
I multiplied the 19 by 4 and then subtracted it by 6.
Good. So what he did is he took the 4, he plugged it in for x into this expression. So 19 times 4 minus a 6. What's that give us?
70.
Good.
And I multiplied it by 2.
Good. So what that means is this one angle is 70 degrees. That means the other smaller angle must also be a 70 degrees. And what the question was asking for is the big angle, ABC. So it is now the sum of those two. So that would be a 140 degree angle. Okay, so lots of process there, which is, again, good stuff. It makes us think a little bit. Okay. All right, next ones. It says use the picture to name an example of each of these. So an altitude first must form a 90 degree angle. If you notice, we have a couple of them. Here's a 90 degree angle. Here is a 90 degree angle. But that initial part of the line segment needs to come from the vertex of a triangle. So is the yellow one here or the blue one here our altitude? Which one forms a 90 degree angle and comes from the vertex of our triangle? Asad? The vertex is these guys. So vertex, one of the corners of our triangle. So it is this blue one here. That is our vertex. Can you see your letters on yours? Okay, I think I moved. Oh, because I moved it all down, didn't I? To make some more room. Let me move this down a little bit so I can see all the letters. Okay, so then it would be this Y, T. So from Y to T extends from our vertex 90 degrees to the opposite side. That's your altitude. All right, angle bisector. Again, just sort of understand what this is saying. We want to bisect an angle. So we only have 3 angles to really concern ourselves with. It's these 3 vertices here, X, Y, and Z. We have stuff extending from all 3 of them, but we need to, and we don't ever guess, don't assume, we need to know that we are bisecting it. So when we look down here to this angle right here, notice these arcs. those arcs are how we show that angles are congruent. So the fact that these two arcs are congruent to each other, these two angles here, that means this line segment right here was cutting this big angle right in half. So our angle bisector has to be XV. All right, so the segment XV. Okay, next one. If we want our median, it cuts the opposite side in half and must come from the vertex. All right, so again, you're worried about your vertex here, here, and here. Which one of those has a segment coming out of it that goes to the other side and cuts it straight in half? Whichever one of those must be our answer. So let me give you the three options here. I'll do this one in blue. I'll do this one in yellow. And then this one is in purple. So only one of those, the yellow one, the blue one, or the purple one, comes out of the vertex and cuts the opposite side in half. All right. Which one is cutting the opposite side in half? Blue, yellow, or purple? Well, good. The yellow one. Because the reason we know that, see these tick marks right here? That's telling us that this segment and this segment are congruent. That means this is the midpoint. So the yellow one is the one that falls right on that midpoint. The yellow segment is UZ. So we would just write the segment UZ. All right, last one. Perpendicular bisector. It must do both of these things. It has to be perpendicular, and it needs to bisect the side. This is the only one of these words that don't have to come from your vertex. So that is this guy now. Notice how it doesn't come from the vertex, but it does go to the opposite side. Notice how it's perpendicular because we see the little square right here. And then we know it bisects because what this thing down here is telling us is this whole length from X to Z, this is the middle of that. All right, so UW is our perpendicular bisector. All right. All right, so just know those, know what they are. All right, another angle bisector here. If I tell you that angle 1 is 5x plus 2, and I tell you angle 2 is 3x plus 20, if this is in fact an angle bisector, then these two guys must be equivalent to each other. So angle 1 must equal or have the same degree measure as angle 2. All right, bisect means we cut directly in half. Okay, and then solve that. Then answer the question. So we hopefully get X to be the 11. Know what angle we're looking for. TVU, similar to the one we did on the front page. TVU is the big overall angle. So it's really angle 1 and angle 2 added together. So take 11. I'll plug it into angle 1. So the measure of angle 1 should be 5x minus a 2. And we now know that that x is 11. So the measure of angle 1 is 53. That means the measure of angle 2 is also 53. And TVU is that big angle, which is these two guys added together. So that should be 106. All right. All right, set up 11, and I hope, yeah, and then we're done with angle bisectors right now. So set up number 11, see if we understand how this one is, again, similar, but a little different. So now in this one, TVU is the first one that they gave you. That is your big angle here. All right, that's the overall angle. And then TVP, that's the 5x minus a 2. Are these two expressions here, do we set these equal to each other in this case? No. All right, these aren't equivalent. This is the big angle, this is the small one. So what Ella did earlier, if this is 5x minus 2, then she said this would also have to be the same exact thing. Those are both the same because they got bisected. So these two guys added together, the 5x plus 2 and then that other 5x plus 2, or minus 2, sorry, those together would equal the overall angle, and the overall angle is that 12x minus a 40. Okay? That's then what we solve. Combine your like terms. Work your way through solving this. So we'll subtract our 10x over. All right, add our 40, and then x equals 18. And again, just with all these, make sure you're answering your question. We want that big overall angle. So find angle 1, find angle 2. We need to add those guys together. All right, so if we plug in 80, what is it? It's 5 times 18 minus a 2, 40. Yeah, 90 minus 2. So those are both 88. We all getting that? All right, I'm trying to do this in my head real quick. All right, and then add those together. Oh, that doesn't make a lot of sense. But then we have 2 of those. So they're both 88 degrees. What is that, 176? Okay. All right, the next set of problems. So here's our next kind of thing here. These are what we call isosceles triangles. And the idea is if these angles are congruent to each other, then the sides that are opposite of them must be congruent to each other. So in this case, that 2x minus 9 would have to be equivalent to 9. All right. And then all you're doing for this one is solving for x. So 2x equals 18. And then x would equal 9. All right, similar rule. Here I'm telling you these two sides are congruent to each other. So that means their opposite angles must be congruent to each other. So if we know this one is 75, then that would also tell us that that one is 75. All right, so that's the properties of an isosceles triangle. Their base angles, the angles opposite of those congruent sides are also congruent. I want you to find the value of x. This now brings us to, for the first time today, probably the one we've dealt with the most in this module, the idea that within a triangle, all those angles have to add up to be 180. So we now just take 75 plus 75 plus this angle 2. You are told what angle 2 is. We add all of those up, and they have to equal 180. All right, that, of all of the things we should know, probably the best. All right, what I'm probably going to do is I'm just going to set these up and trust we can solve these. I want to make sure we get as many of these done as we can. But that's how you're setting that up, and then you just solve the equation, combine your like terms, solve that for x. Okay? All right, go to number 14. Again, the problem that we have done the most. Here is a triangle. I tell you that angle A is 2x plus 8. Angle B, 3x plus 12. Angle C, x plus 4. What I've really given you is the 3 angles inside of that triangle. Again, what we've done the most this whole first 3 weeks back from break, all those have to add up to be 180. Inside of a triangle always adds up to be 180. So we take 3x plus 12, x plus 4, 2x plus 8. Those have to all add up to be 180 degrees. All right, so here's 1 angle, 2 angle, 3 angle, add them up to be 180. All right. At this point, again, we're all pretty good with the equations. All right, 15. We identified what a median was, and now we just want to use the problem. So again, a median is the idea that this A to B has to be cutting that opposite side in half. So that means C to B and B to D have to be congruent. This is a midpoint. We've used that word some too. Well, then I tell you that CB is 3x plus 6. And then from B to D is 7x minus 34. Since this is a median and we know that that side got cut directly in half and we put these tick marks here, that is just telling us that those have to be equal to each other. They have to have the same lengths. All right, so you set them equal to each other. Solve that. Although again, let's just set these up to make sure we know where the setup comes from, because I think we better be good at solving equations at this point. You solve that for x, make sure you answer your question. Okay. All right, 16. All right, let's move from 16. Go to number 17. Let's do some. I want to make sure we see one of each thing. 17, probably the one that people have asked the most questions about with all of this. The idea that you have your triangle. So here is our triangle. And you have 2 of the 3 angles inside. This is what we called an exterior angle. The angle that's outside of the triangle, if we extended one of those angles. What is always true is that this exterior angle right here, this 12x minus a3, is always equal to the interior angles that are across from it, that are remote to it, that are away from it. So this 40 and this 10x plus 90, if we were to add those up, that always equals our exterior angle. All right. So in 18, if I had you set that one up, this is saying that this angle here, this is our exterior angle, the 142 degree angle. I don't know, it's still on my computer here. I don't know, that's really weird.
The light's still on.
I don't know, it's up here. Interesting. No, it isn't. It just died.
Wow.
Did the bulb die? What the? All right, set that one. We should set that up. So the 142. That's right on the board, I suppose. Although now we get the words here. It has to equal the 4x minus 3 over the 6x minus a5. Let's see what happens. Now my, there we go. Light bulb might have burned out. It's not coming. Oh, there it comes. All right. The nice thing is, hopefully, 19 through 22, the last 4 problems, are all fairly nice, I would hope. All right, let's see. There we go. All right, so that last one, the 142 then has to equal the sum of those angles that are across from it. So that should have been your equation for that one. Okay. So that's our X. Be careful of that one. That is, again, probably the one that people just don't see the best on all of the theorems that we do. Then 19 and 20 are pretty much the same question. We'll do one of each of these just to kind of make sure we see one of each since we ran out of some technical issues here. So I'm telling you that M is the midpoint of segment RT. So when we did these, I would have you draw this out. So the segment RT, that's what I'm telling you this is. And then there's this point M that is directly in the middle of it. As soon as you're told that it's in the middle, that means it got bisected. That means this segment here and this segment here have to be congruent to each other. Then you are told what each of those are. From R to M is a 5x plus a 9. And then from M to T is an 8x minus a 36. All right. Since these we know we have these tick marks, they got bisected, these have to be equal. So we take those two little expressions there. Those lengths have to be the same, so we set them equal to each other, and then again, work your way through, solve that equation. We can all do that pretty nicely. Okay, 20 I'll leave you so we can get to the last one. You should get 16.5 though, real quick, if you want to write that down. That's your answer. And then let's make sure we do one of these. Now, these are our most recent things. I had to do a little quiz on this yesterday, so you should have seen plenty of these yesterday. When I tell you that angle A and B are complementary, Lily, what's complementary mean, Lily? Good. So those add up to be 90 degrees. So that simply means angle A plus angle B better be added up. And when we do that, they need equal 90 degrees. The next sentence then tells you what each of those are. Angle A is 4x plus 24. Angle B, I tell you, is 3x minus a 4 equals 90. Solve that. So combine your like terms. So you get 7x plus 20 on the left-hand side. Subtract that 20 over to the 90. X equals 10. And again, answer the question tomorrow. Again, first test, 50% of your grade is going to stick with you for a while. We want the measure of angle B. So here is the measure of angle B. So the measure of angle B is 3 times x minus a 4. Should give us 26 degrees. Okay. A reminder, because I think there's about 6 or 7 people. I want to say there's 3 of you in here. If you haven't done this quiz from yesterday, all the complimentary, supplementary stuff that you worked on in class, that is open until 10:15. So you have through second period to get that taken care of. So please make sure that is done. That'll hurt a grade very quickly. And then number 2, we won't go all the way through it. Just know supplementary. Again, we just quizzed on this yesterday, so this should be very fresh. Is 180. So those have to add up to be 180. All right. Yeah.
For the Delta Math, I was asking this.
So if you go to Delta Math, what do you got going next period? Do you have any major assignments due this week or today, tomorrow, other than that?
I could do that.
I don't see that. It's all in terms of extending it just for you. I'll do my best. Let me write it down. Next period, I'll try to fumble around with it a little bit and figure out how I can extend it. Now I got it right now. Just give it in one day, right? It says, I found it before. I couldn't do it quickly. One day, because that should be tomorrow at 10:15. Figure that. Until tomorrow at 10:15. Lily, how'd the last 2 days go?
Good.
How was the bikes?
It's good.
Yeah?
Are we inside or?
We'll probably be outside. I'm gonna drive the neighborhood again real quick. I'm hoping after a few days that should be clear. Temperature wise, though, it's going to be pretty reasonable. So I would certainly play the algebra. Okay.
Mr. Kenny,
Yeah.
did I get these two answers right?
Armando. Almost. This is all good.
Yeah.
Just on the quiz or test tomorrow, just use your calculator. Be careful. 52 divided by 2 is 26 and not 36.
Oh, I meant to put 26.
Okay.
I just.
Then that's correct. And then the same thing. -3, -5.
Oh,
When we
positive.
combine, nope.
I thought-
When we combine a negative, it's kind of like I lost $3.
Yeah.
You lost $5. If you combine what we just did, we didn't come ahead. We didn't earn 2. You lost 3. I lost 5. Overall, we've lost 8.
Oh, okay.
So a -3, -5 would just give us a -8.
Okay.
And then that's what you're going to move to the other side.
Okay.
Okay. So you're setting it up right. Just be careful with the algebra and be careful with the computations
And
there.
then for this one, do I just plug the answer into like
CD.
CD?
Yeah, so it's another one where CD is the full length, but we know these two are equal. So if I took 10 and plug it in right here, what's 3 times 10?
30, so 36 then.
This also has to be 36.
Oh, so 36 would be the answer then?
Nope,
If it's the same.
because we want the full thing.
Oh, add 36 times 2.
Right.
Okay.
Yep.
I have 2 assignments from last week.
Okay, I'll take it. Oh, I could really use those extra 8 minutes.